Hello everyone, in this video we'll be talking about genetic algorithm. My name is Aditya. So let's start this video. Coming to the introduction of genetic algorithms are computational techniques inspired by the process of natural selection and evolution, introduced by John Holland in 1960s and popularized in his book Adaptation in Natural and Artificial Systems. Genetic algorithm mimics the process of natural selection to evolve potential solutions to optimization and search problems. These algorithms are particularly useful in various fields, like for complex, nonlinear, and multi-dimensional optimization problems. Genetic algorithms are based on the principle of selection, crossover, and mutation. Some basic terminologies that are used in genetic algorithms are chromosome. What is a chromosome? A representation of a potential solution, typically encoded as a string of binary digits or real numbers. Gene, a component of chromosome representing a parameter or a variable of the solution. Population, a connection of chromosome representing the initial pool of potential solution. Fitness function, a function that evaluates the quality or fitness of a solution. Generation, each iteration of the genetic algorithm where a new population is generated from the previous one. Talking about how a flowchart of a genetic algorithm works is starting by population initialization. You randomly generate an initial population of chromosomes. Fitness evaluation, you evaluate the fitness of each chromosome using the fitness function. Selection, select chromosomes from the current population to serve as a parent for the next generation. Crossover, create new offspring chromosome by exchanging genetic information between selected parents. Mutation, introduce random changes in the offspring chromosomes to maintain diversity. Reproduction, from the next generation of the population by combining selected parents and mutated offspring. And termination, repeat the process for a predefined number of generations or until a termination condition is met. Talking about population initialization, the genetic algorithm starts by creating an initial population of potential solutions. Each solution is represented as a chromosome, typically encoded as a string of binary digits. The population, size, and chromosome representation are critical parameters in genetic algorithm design. The initial population is typically generated randomly, but it can also be generated using heuristics or problem-specific knowledge. The size of the population and the encoding of the chromosome depend on the problem domain and the characteristics of solution space. Fitness evaluation. The fitness function evaluates how well each solution performs in solving the problem. Solutions with higher fitness values are more likely to be selected for reproduction. The fitness function guides the genetic algorithm towards finding optimal solution. The fitness function evaluates how close a solution is to the desired outcome. It assigns a numerical value to each chromosome based on its performance or suitability for the given problem. The goal is to maximize or minimize the fitness value depending on the optimization objective. Selection. In the selection phase, individuals from the population are chosen for reproduction based on their fitness. Solutions with higher fitness values have a higher probability of being selected. Different selection strategies such as rounded win selection and tournament selection can be used. Selection determines which chromosome from the current population will be chosen as parents for the next generation. Various selection methods can be used such as rounded win selection, tournament selection, or rank-based selection, as I've told you earlier. The probability of selection is proportional to the fitness of each chromosome, favoring better solution. Crossover is a genetic operator that combines genetic information from two parent solutions to create new offspring. The crossover point determines whether genetic material is exchanged between parents. The process introduces diversity in the population and helps explore new regions of the solution space. Crossover also is sometimes referred to as recombination. It involves combining genetic information from the two parents' chromosomes to create new offspring. Different crossover techniques such as single point crossover, multi point crossover, or uniform crossovers can also be used. The goal is to explore the search space by creating offspring that inherit beneficial characteristics from their parents. Talking about mutation. Mutation is a genetic operator that introduces random changes in the offspring genetic material. It helps prevent premature convergence by maintaining genetic diversity in the population. The mutation rate controls the probability of gene being altered in the offspring. Mutation introduces random changes in the offspring chromosome to maintain genetic diversity. It helps prevent premature convergence by exploring new regions of the solution space. Mutation typically involves stripping or altering individual bits or genes in the chromosome with a low probability. Talking about reproduction, after selection, crossover, and mutation, the offspring replaces the least fit individuals in the population. The new population is then evaluated using the fitness function to determine the next generation quality. The iterative process continues until a termination condition is met, such as the maximum number of generations. Reproduction combines selected parent chromosomes and mutated offspring to form the next generation. The offspring population replaces the current population, maintaining a fixed population size throughout the evolution process. The new population is then subjected to fitness evaluation, and then the selection process continues iteratively. Talking about some of the advantages of genetic algorithm is that it does not require any derivative information. It is faster and more efficient as compared to a traditional method, has a very good parallel capability, optimize both continuous and discrete functions, and also multi-objective problems. Provide a list of good solutions and not just a single solution. Some more advantages can be genetic algorithms are capable of finding near optimal solution in complex search spaces with multiple local optima. They are inherently parallelizable and can handle problems with a large number of variables or constraints. Genetic algorithms are versatile and can be applied to a wide range of optimization and search problems without requiring problem specific knowledge. With advantages, there are some certain disadvantages of genetic algorithms. Some of them are genetic algorithms are not suitable for problems, especially problems which are simple and for which derivative information is always available. Fitness value is calculated repeatedly, which might be computationally expensive for some problems. There are no guarantees on the optimality or the quantity of the solution. If start implemented properly, the genetic algorithm may not converge into the optimal solution. They are sometimes also computationally expensive, especially for problems with large search spaces or complex fitness functions. There is no guarantee of finding the global optimum, and the algorithm may converge to the local optimum instead. Turning the parameters of the genetic algorithm, such as population size, crossover rate, and mutation rate, can be challenging. Some of the applications of genetic algorithm could be that genetic algorithms are already used in various fields, including optimization, machine learning, and computer science. They apply to a problem like scheduling, routing machines, learning model optimizations, and gameplay. Genetic algorithms can find solutions to complex problems where traditional optimization techniques may struggle. I would like to now conclude this video by a few points. Genetic algorithms are powerful optimization techniques inspired by the principles of natural selection and evolution. By leveraging selection, crossover, and mutation, genetic algorithms can find high-quality solutions to complex problems. Understanding the key components and parameters of a genetic algorithm is essential for designing effective optimization strategies. Thank you for watching this video till the end. I hope this video was knowledgeable and you could find something helpful out from it. Thank you.